Dr. R. Hemavati is an assistant professor in mathematics in Queen Mary's, Chennai. She has specialized on functional analysis. Having 12 years of experience in teaching, she has won various awards for her performance. She has published papers in 14 international journals, 3 national journals, and has presented papers in 10 international and in 5 national conferences. She is also one of the editors for an international journal.
Welcome to UGC lecture series. In the previous sessions, we were talking about a test of significance based on large sample and small sample. In large sample we have seen Z test, and in small sample we have seen T test, F test and chi-square test. Also we have discussed sampling distributions of mean, proportion, variance, etc. After studying the test of significance for mean, variance and frequencies, it is appropriate to study the sampling distribution revisiting it. So, sampling distribution of mean and proportion will be studied in this session. So, the objective of this session is to study in detail about the sampling distributions of mean and proportion in sampling with replacement and without replacement respectively. Sampling distribution of a sample mean. The sampling distribution of a sample mean in the case of a sampling with replacement in the sense when the sample is done on a random process, the sample items taken are replaced into the same sample for taking another sample, another item. Each sample value becomes independent in this case. So, suppose x is a random variable with mean mu and standard deviation sigma defined on some population. A random sample of size n drawn with replacement yields n values x1, x2, etc. up to xn, each with mean mu and standard deviation sigma. For example, if x is the age of college graduates in a given year, then xi would be the age of the ith graduate, I is equal to 1, 2, 3, etc. up to n. That is, x1 stands for the age of the first graduate and x2 stands for the age of the second graduate, like that xn stands for the age of the nth graduate in a random sample from this population of college graduates. The random variable x bar is equal to x1 plus x2 plus etc. plus xn, which are the averages of these xi values, is called a sample mean of x1, x2, etc. up to xn, where each xi stands for the age of the ith graduate. As a random variable, x bar can be treated like x, a random sample value. So, x bar has a mean mu x bar and a standard deviation sigma x bar. Now, when x bar becomes a separate random variable, we can discuss the mean and standard deviation of x bar in the case of sampling with replacement. This is the theorem related to speaking about mean and standard deviation of x bar as a separate random variable in the case of sampling with replacement. Suppose a population random variable x has mean mu and standard deviation sigma, then the sample mean x bar for random samples of size n drawn with replacement has mean mu x bar and standard deviation sigma x bar given by mu x bar is equal to mu and sigma x bar is equal to sigma by root n. Furthermore, if x is normally distributed, x as a separate random variable, then x bar is also normally distributed approximately. Now, this example will give you a typical picture about how the population mean and standard deviation are calculated for an equiprobable sample space. Let us see. Example 1 says a population consists of the set S is equal to 4, 7, 10 as an equiprobable space. Equiprobable space in the sense appearance of 4 has chance 1 by 3. Similarly, appearance of 7 has a chance of 1 by 3. Appearance of 10 has a chance of 1 by 3. Similarly, random samples of size 2. Size 2 in the sense 2 items are taken out of 3. That is 4,7 is one particular sample, is a sample of size 2. Similarly, 4,10 is another typical sample of size 2. Like that, it is taken or drawn with replacement. In the sense, when the sample values 4, 7 are taken from the population, they are again replaced into the population for taking another sample. That is what is called sampling with replacement. Compute the population mean mu and standard deviation sigma. Usually, when the population is infinite, these particular values mu and sigma will be already determined and given to you for calculation purpose. We will be calculating only sample mean and sample standard deviation for a particular values of sample from the population. But here you are asked to calculate population mean and standard deviation itself. So, find the sampling distribution, that is a probability distribution for the sample mean x bar. Compute the mean mu x bar and standard error, standard deviation of the sampling distribution is also called as standard error. This terminology we have already discussed when we are discussing about terminologies related to sampling in previous sessions. And compare with the mu and sigma, which are the population mean and population standard deviation respectively. Okay. So, we shall do this problem. Now, we have a space as equiprobable space, that is S is equal to, you are given 4, 7 and 10. Therefore, the mean and standard deviation of the population having these three values will be mu is equal to summation x into p of x. This is like usual calculation of mean, expectation of random variable x, e of x is equal to summation x into p of x. This kind of calculating the mean we have already seen in statistical methods 1. So, summation x into p of x is 4 into its probability is 1 by 3. So, 7 into 1 by 3 plus 10 into 1 by 3 x into p of x. So, this calculation gives you 21 by 3 is equal to 7. So, mu is equal to 7, that is mean is equal to 7. Okay. Next, we have to calculate standard deviation. The standard deviation is actually sigma. Sigma is expectation of x square minus expectation of x the whole square, or you can calculate this as summation x minus mu whole square into p of x. This we have to calculate using the tabular column. First, the x values are narrated here 4, 7 and 10. Then x minus mu, which is x minus mu we have just calculated, it is 7. So, 4 minus 7 is minus 3, 0, 3. Then x minus mu whole square values will be 9, 0, 9, and this total comes to be equal to 18. So, x minus mu whole square into p of x, this is what is your sigma root of summation x minus mu whole square into p of x. Here actually this is sigma is equal to square root of e of x square minus e of x whole square, and is also square root of summation x minus mu whole square into p of x. Only variance is e of x square minus e of x whole square. Standard deviation is square root of variance, and therefore you have to put square root. Okay. This is equal to square root of 9 into its probability is 1 by 3, again 0 into 1 by 3 plus 9 into 1 by 3. This is equal to root of 18 by 3 is equal to root 6. Okay. We have found out the answer for the first question, that is compute the population mean mu and standard deviation sigma. Now, the answer is actually mu is equal to 7 and sigma is equal to root 6, is equal to root 6. Next, you are asked to find out the sampling distribution for the sample mean x bar. So, the sampling distribution for sample mean will be given in a tabular column. That is, first of all, the x bar values are written. Sampling distribution, samples of size 2 are taken with replacement. So, samples of size 2 are taken with replacement. So, what are the possibilities? What are the possibilities and what are its corresponding average that we have to calculate? That is, these are the sample of size 2 and its corresponding x bar. 4, 7, 10 is actually the population values from the EQ probable space. Therefore, of size 2 the possibilities are 4, 7, 4, 10, and then first 4, 4, 4, 4, 4, 7 and 4, 10. Corresponding to 7, you take 7, 4, 7, 7, 7, 10. Corresponding to 10, you have 10, 4, 10, 7 and then 10, 10. What are its average? 4 plus 4 divided by 2 is equal to 4. Next, 4 plus 7 divided by 2 is equal to 5.5. Like that, the x bar value is calculated. 7, 5.5, again 7, 8.5, 7, 8.5 and 10. So, this is actually written to calculate x bar for each sample of size 2. Okay, next we will write down the sampling distribution of x bar. That is what is your B part. Sampling distribution of x bar. What are the x bar values? Without repetition, you have to take x bar is 4, then 5.5, 7, 8.5, then 10. What are its corresponding probability values? P of x bar. How many times 4 is repeated? Just see. Now, how many values are there? First of all, here totally 9 values are there. 1, 2, 3, 4, 5, 6, 7, 8, 9. So, out of 9 values, 4 has got 1 chance. Therefore, it is equal to 1 divided by 9. Now, next see how many times 5.5 has appeared. 5.5 has appeared 2 times in 9 possibilities. Okay. So, therefore, 5.5 will have 2 by 9. And similarly, see 7 has appeared 3 times, right? 1, 2, 3. 3 times 7 has appeared. Therefore, it is 3 by 9. How many times 8.5 has appeared? 8.5 has appeared 2 times. Next, 10 has appeared 1 time. So, this is 2 by 9 and this is 1 by 9. Just check whether total probability comes to be equal to 1. 1 by 9, 1 plus 2, 3, 3, 6, 8, 9. 9 by 9 gives you total probability is 1. Therefore, this is appropriate sampling distribution of x bar or otherwise probability distribution of x bar. This is how the tabular column is formed. Next, you are asked to find out the mean and standard deviation for this particular distribution, sampling distribution. Mean is equal to mu x bar is actually summation x bar into P of x bar. Summation x bar into P of x bar, which is equal to 4 into 1 by 9 plus 5.5 into its corresponding probability is 2 by 9 plus 7 into 3 by 9 plus 8.5 into 2 by 9 plus 10 into 1 by 9. What is this total? Total is 63 by 9, which is equal to 7. Just recall, we have calculated the population mean mu as 7 and this value is also 7. Therefore, comparing we see mu x bar is equal to mu is equal to 7. Okay. Next, we will calculate the standard deviation. Standard deviation is calculated as root of a summation x bar minus mu whole square mu x bar into P of x bar. That is, just write down the x bar values and mu of x bar values. X bar values is 4, 5.5, 7, 8.5 and 10, and x bar minus mu x bar is nothing but x bar minus 7. So, minus 3, and 5.5 minus 7 is minus 1.5, 7 minus 0, 1.5, then 3. Then its square, x bar minus mu x bar whole square. 3 square is 9 and 1.5 square is 2.25, then 0, this is 2.25. Here actually x bar minus 7 is minus 1.5. Actually your x bar minus 7 total should be 0, then only your calculation of x bar minus mu x bar square will be correct. So, 1.5 square is 2.25 and here it is 9. Then x bar minus mu x bar whole square into p of x bar minus mu x bar whole square into p of x bar. Just check p of x bar values in your previous tabular column. For 4 corresponding to 4 it is 1 by 9, 2 by 9, 3 by 9 like that. Okay. So, 9 into 1 by 9. This p of x bar values is already there in the previous tabular column. Is 1 by 9, 2 by 9, 3 by 9, 2 by 9 and then 1 by 9. Okay. So, next is this is 2.25 into 2 by 9, 0 into 3 by 9, then 2.25 into 2 by 9, next 1 into 1 by 9. Okay. So, this total standard deviation comes to be equal to root of 27 by 9, which is equal to root 3. Okay. Whereas sigma of population, that is standard deviation of population, is root 6. We shall check whether sigma x bar is equal to sigma by root n. This is we have to verify to check. Sigma x bar we have just calculated as root 3. So, this is root 3 and you are having sigma is root 6 and root n. There are 3 values in the sample. The samples are taken of size 2, therefore 2 samples are of size 2, 4, 7, 4, 4 like that. This is root of 6 by 2 is equal to root 3. So, hence we have verified sigma x bar is equal to sigma by root n. That is what you are asked to compare with the population values and sample mean standard deviation values. Okay. So, ultimately we write down the result mu x bar is equal to mu is equal to 7 and sigma x bar is equal to sigma by root n is equal to root 3. Hence, we have done this problem. Next, we shall discuss the sampling without replacement. In sampling without replacement, the sample values are not replaced for consideration into another sample. So, each sample value is dependent on the previous ones. So, I will just discuss like that. If samples are drawn without replacement, then the sample values x1, x2, x3 etc. up to xn of a random variable x are not independent, because for drawing x2, x1 is not replaced. So, the sample space number will be reducing. Therefore, x2 is dependent on x1, similarly x3 is dependent on x2, like that it is dependent on the previous values. Nevertheless, the average of the values, namely x bar is equal to x1 plus x2 plus etc. x up to xn divided by n, defines a random sample variable which will be denoted by x bar and also will be called as the sample mean. Now, we shall discuss the mean and standard deviation of x bar for sampling without replacement. Suppose a population random variable x has mean mu and standard deviation sigma. Then the sample mean x bar for random sample of size n drawn without replacement has mean mu x bar and standard deviation sigma x bar given by mu x bar is equal to mu and sigma x bar is equal to sigma by root n into root of capital, this is called a correction factor. Root of capital N minus small n divided by n minus 1 is called a correction factor for the standard deviation. This is used when the population is finite. Here actually, since the samples are drawn without replacement, the population size becomes lesser. in the sense the population is becoming finite, and hence we calculate the standard deviation, that is the standard error of sample mean as sigma by root n divided into root of capital N minus small n by n minus 1, where capital N stands for the population size and n is less than capital N. In this case, the mean and standard deviation of x bar are given by theorem 2, and where n is the size of the population and small n is sample size and capital N is population size, always sample size should be lesser than population size. Furthermore, if x is, as discussed in the theorem 1, if x is approximately normally distributed, so is x bar, that is x bar also will be normally distributed. We should do this problem, the same problem of the sample space S 4, 7, 10, but the sampling is done without replacement. So, assume that random samples of size 2 are drawn without replacement from the population S is equal to 4, 7, 10 as an equiprobable space. Find the sampling distribution for the sample mean x bar, and you are also asked to calculate mu x bar and standard error, that is standard deviation of x bar, and compare it with the population mean mu and standard deviation sigma. The population mean mu and standard deviation sigma is same, that is mu, and because the same sample space, right, therefore population mean mu is 7 and standard deviation sigma value is root 6. Okay. As done in example 1, population mean will not differ. In example 1, mu is equal to 7, there is no change in population mean and the population standard deviation, which is root of 6. Okay. Now, we shall find out the sampling distribution for the x bar. First of all, samples of size 2 without replacement. Without replacement, in the sense 4, 4 will not appear. Once 4 is taken, 4, 7, 10 are the 3 values in the population to be considered for sampling. Okay. Sampling is done without replacement. So, once 4 is taken, 4 again will not be considered for sampling. So, 4, 4 as in the samples of size 2 with replacement will not come. Okay, here taken 4, 4, that will not appear here. So, 4, 7, 4, 10, these are the samples of size 2. Then with respect to 7, we have only 7, 10. And what is its corresponding x bar values? For 4, 7 is 5.5, 7 and 8.5. The sampling distribution for this case, sampling distribution for this case, sampling distribution of x bar without replacement. In this case is we have only 3 values of x bar, that is 5.5, 7 and 8.5, and its chances are 1 by 3, 1, because 5 is appearing only one time, 7 is appearing one time, so 1 by 3, and 8.5 is also appearing one time among the 3 values 5.5, 7 and 8.5. So, this is the sampling distribution of x bar values 5.5, 7 and 8.5 with respect to their probability values. Okay. Now, we shall compute mu x bar, just to calculate x bar into P of x bar for calculation for mu x bar 5.5 by 3, 7 by 3, then 8.5 by 3. Okay. The total comes to be equal to mu x bar is equal to summation x bar into P of x bar, which is equal to 5.5 by 3 plus 7 by 3 plus 8.5 by 3, which is equal to 21 by 3 equals to 7. Now, we can check mu x bar is equal to mu value is equal to 7. Okay. Next, we calculate x bar minus mu values. X bar is actually 5.5, 7, 8.5. X bar minus mu is x bar minus 7, that is minus 1.5, 0, 1.5, and its corresponding square values x bar minus mu whole square is 2.250, then 2.25. Next, x bar minus mu whole square into p of x bar, or we shall calculate a standard deviation sigma x bar is equal to summation x bar minus mu whole square into p of x bar. So, summation x bar minus mu whole square into p of x bar, this is equal to 2.25 into 1 by 3 plus 0 into 1 by 3 plus 2.25 into 1 by 3. Okay. And this value comes to be equal to root of 4.5 by 3, which is root of 1.5, that is your sigma x bar. Now, sigma x bar, to verify or to check whether sigma x bar is equal to sigma by root n. Actually, here your sigma x bar is sigma by root n into root of capital N minus small n by capital N minus 1. Okay. What is your sigma x bar value? This is 1.5. You are having 3 values 4, 7, 10 in population. Therefore, capital N is equal to 3. So, 3 minus samples are taken of size 2. Therefore, small n is equal to 2. So, root 6 by root 2 into root of 3 minus 2 by 3 minus 1, root 3 into root of 1 by 2, that is root of 3 by 2 is equal to root of 1.5, hence verified. So, that is verified, we have proved that sigma x bar is equal to sigma by root n into root of capital N minus small n by n minus 1. After discussing about sampling distribution of sample mean, next in continuance we have sampling distribution of sample proportion. That is, suppose a proportion P of population favoring candidate A for president post. In this random sample of size n drawn from the population, a certain proportion P bar of the sample will favor the candidate A, and the collection of all such proportions defines a random variable P bar called the sample proportion. Now, the mean and standard deviation of the P bar are given in the next two theorems, which will be discussed in the next session. Now, in this session, sampling distribution of mean and proportion have been discussed in detail with respect to the sampling with replacement and without replacement. Related central limit theorems are also put up for discussion. Some problems have been worked out for deriving the sampling distribution of sample mean in sampling with replacement and without replacement. To understand the concept of sampling distribution of mean in sampling with replacement and without replacement. Based on the discussion in this session, the following questions may be posed. Let S is equal to 1, 5, 6, 8. Find the probability distribution of the sample mean x bar for random samples of size 2. Here we have the population size as 4. Out of the population size of 4, random sample of size 2 are drawn with replacement. Okay, so, you are asked to find out the probability distribution. Next, similarly find the probability distribution of the sample mean x bar for random samples of size 2 for the sampling without replacement. Thank you.